welcome to another deep dive with us. Today we're diving into a really cool article from Live Science.
Oh yeah, I saw that one.
Yeah, it's called Scientists Discovered Giant Galaxy 32 Times Bigger Than Earth's, and they named it Trouble.
Catchy title.
Right. And it was just published February 5th, 2025, so very, very recent.
Yeah, fresh off the press.
So this discovery is causing a bit of a stir in the astronomy world because it really makes us rethink how common these giant radio galaxies might actually be out there.
Yeah, and to really get why this is such a big deal,
Yeah.
I think we need to start with,
Yeah.
what powers these incredible objects?
Okay, so back to basics a bit.
Yeah, just a little bit.
So we're talking about supermassive black holes.
Right.
Millions or even billions of times the mass of our sun.
Exactly. And these black holes, they're not just sitting there.
No.
They're actively pulling in just huge amounts of gas and dust.
Okay, so how do we picture this?
So picture material spiraling inwards towards the black hole, forming this swirling disk around it.
Like a whirlpool.
Yeah, like a cosmic whirlpool.
Okay, cool.
And all this swirling and friction, it generates an incredible amount of energy.
Right, so this is where that whole rave party analogy comes in.
Exactly. All this energy is released across the electromagnetic spectrum,
Oh, wow.
creating these dazzling displays of light and radiation.
Right.
And some of these black holes, they even launch these jets of superheated matter that we call plasma,
Plasma, okay.
millions of light years across space.
So these are like cosmic laser beams shooting out from the black
Oh.
hole.
Yeah, that's one way to think about it.
And these beams, or jets, I guess is the more accurate term.
Right.
These are what make a galaxy a radio galaxy.
Exactly. These jets emit radio waves, which we can detect here on Earth with powerful radio telescopes.
Cool.
And as these jets blast outwards over time, they can push out into the surrounding space, creating these incredibly large structures that we call giant radio galaxies.
Giant radio galaxies, okay.
And for a long time, astronomers thought these giant radio galaxies were pretty rare.
Like a fluke almost?
Yeah, almost like cosmic oddities.
Okay.
But thanks to new telescopes, like the MeerKAT telescope in South Africa, that view is changing.
Oh, really?
MeerKAT has discovered thousands of these giant radio galaxies.
Thousands.
Yeah, in just a few years.
So they're more common than we thought.
It seems that way.
Okay, that's really interesting.
It really changes our perspective.
Yeah, so this brings us to this new discovery, this new galaxy, Inkathazo.
Yes, Inkathazo.
So tell me a bit about this name.
Well, Inkathazo means trouble in Isikxhosa and isiZulu.
Trouble.
And let me tell you, it's living up to its name.
Okay, so lay it on me. Why is Inkathazo causing so much trouble for scientists?
Well, for starters, it's absolutely massive.
How massive are we talking?
We're talking 3.3 million light years,
3.3 million.
which is about 32 times the size of our own Milky Way galaxy.
Wow, that's huge.
Yeah, it's like finding a whale in your bathtub.
Okay, so it's big, I get it, but is it just the size or is it something else?
Well, it's not just the size. It's the fact that this is the third giant radio galaxy found in a relatively small patch of sky.
Okay, so 3 in one small area.
Imagine searching a tiny portion of the ocean and finding 3 blue whales.
Oh, wow. Yeah, that's a lot of blue whales.
Yeah, so it really makes us wonder just how common these giant radio galaxies really are.
Right, so what we thought were rare might actually be pretty common.
That's the question Inkathazo is forcing us to ask.
Okay, so it's big. It's not as rare as we thought it might be.
Right, and there's something else about its shape.
Oh, so it's not just the size.
It's not just the size.
What about the shape is so unusual?
Well, most giant radio galaxies have these straight symmetrical jets.
Okay.
But one of Inkathazo's jets is bent.
Bent.
Yeah, like someone took a cosmic blowtorch and gave it a twist.
Okay, I'm picturing that.
That bend suggests that something is interacting with the jet, pushing it off course.
Oh, wow.
It's a sign that this galaxy isn't just sitting in empty space.
Right.
It's actively interacting with its environment.
Right. So what kind of environment are we talking about here?
Well, that's where things get even more interesting.
Okay.
Inkathazo is nestled right in the middle of a galaxy cluster.
Okay, so it's not alone?
No, not at all. A galaxy cluster is a dense region packed with hundreds or even thousands of galaxies.
So it's a crowded neighborhood.
You could say that.
But wouldn't that make it harder for the jets to grow so large?
You would think so, right? The dense environment of a galaxy cluster should make it tough for these jets to propagate over such vast distances.
Yeah, it's like trying to do a cartwheel in a crowded elevator.
That's a good analogy.
So it's big, it's got a bent jet, and it's living in a crowded neighborhood.
Inkathazo is breaking all the rules.
It really is. So it sounds like scientists are really intrigued by this galaxy.
Oh, absolutely. It's challenging our assumptions about how and where giant radio galaxies form.
Right.
It's forcing us to rethink our models.
Okay, so how are scientists trying to unravel this puzzle?
Well, the same telescope that discovered Inkathazo MeerKAT is also providing some answers.
Okay, so
it can create these incredibly detailed maps called spectral maps that are kind of like a cosmic time machine.
Wait, a cosmic time machine. Tell me more about these maps.
Well, these maps show us the age of the plasma within the jets.
Okay.
By analyzing the different colors or wavelengths of light emitted by the plasma, we can trace its history.
So different colors represent different ages of the plasma?
That's the idea.
Wow, that's really cool. What have we learned from these clues so far?
Well, the spectral maps have revealed something unexpected.
What is it?
Some of the electrons within Inkathazo's jets are getting these sudden bursts of energy.
Bursts of energy, okay.
Like they're hitting cosmic speed bumps.
Cosmic speed bumps. I like that analogy.
So the leading theory is that these energy boosts are coming from collisions with the hot gas that exists between galaxies in the cluster.
Okay, so the jet is plowing through this gas, and it's creating turbulence.
Exactly. Imagine the jet creating a wake as it moves through this intergalactic medium.
So the jet is almost like surfing on the waves of hot gas, and that's giving the electrons an extra kick. It's a possibility.
That's fascinating.
It really is.
So we're not just seeing this giant bent radio galaxy.
Right.
We're seeing evidence of really complex physics happening within the jets themselves.
You got it. And that's what makes this discovery so exciting. It's pushing us to refine our understanding of plasma physics in these extreme environments.
Wow.
Yeah.
So Inkathazo is not just defying expectations with its size, shape, and location.
Right.
It's also showing us that there's more to these giant radio galaxies than we ever imagined.
Yeah, it's a real game changer.
It sounds like it.
Yeah.
It's really making us rethink a lot of what we thought we knew about these giant radio galaxies.
Yeah, it's really a paradigm shift. You know, for years we thought these
Yeah.
massive radio galaxies needed all this space to grow.
Right, like they needed their own cosmic dance floor.
Exactly. No walls, no ceilings to bump into.
Right?
But then here's Inkathazo just thriving in the middle of a crowded galaxy cluster.
I mean, and not only is it surviving there,
Right.
it's creating these crazy powerful jets.
That are bending and weaving through this chaotic environment.
Yeah, it's wild.
I'm still really stuck on that bent jet.
Yeah.
I mean, it's almost like a cosmic fingerprint, right?
Yeah.
Telling us something messed with it.
It's a sign that Inkathazo's jets were interacting with all that hot, dense gas that fills the space between galaxies in the cluster.
Right. So instead of just blasting out into empty space,
Yeah.
it's having to push through all this stuff.
Exactly. It's not just an empty void out there.
Right. So that's probably why we're seeing those energy boosts.
Yeah, it's possible that those energy boosts are a direct result of the jet's interaction with this intergalactic medium.
Oh, wow.
Yeah, it's like the jet is stirring the pot,
Yeah.
creating turbulence and shock waves that energize the particles within it.
So Inkathazo is really pushing the boundaries here.
It really is.
I mean, it's showing us that these objects can exist
Yeah.
in places that we never thought possible.
And that brings up a really important point.
What's that?
If Inkathazo can form and grow in a crowded cluster, maybe these giant radio galaxies aren't as rare as we thought.
Right, because these clusters are everywhere.
Galaxy clusters are pretty common throughout the universe.
Right.
So if they can support these objects,
There might be a lot more out there.
it's entirely possible.
Wow. So what we thought was rare
Yeah.
might actually be pretty common.
That's one of the big questions Inkathazo is making us ask.
This is why I love science.
Me too.
It's like one discovery, one troublemaker like this
Right.
can totally rewrite the textbooks.
It really is the thrill of the unknown, right?
Yeah.
The possibility that we could be totally wrong about what we thought we knew.
Exactly. And it all starts with these observations.
Nice.
With amazing instruments like MeerKAT.
Exactly. MeerKAT is giving us this incredible detail.
Yeah. What else has MeerKAT shown us about Inkathazo?
Well, MeerKAT has allowed us to study the structure of the jets in incredible detail.
Oh.
We can see how they twist and turn, how they interact with the surrounding gas.
And you said we can even measure the speed.
Yeah, we can measure the speed of the plasma within the jets.
Okay, so just how fast are we talking?
We're talking speeds that are a significant fraction of the speed of light.
Whoa.
These jets are blasting outwards at incredible velocities,
Wow.
carrying with them huge amounts of energy.
I'm trying to even imagine that kind of power.
It's mind-blowing.
Yeah, sculpting galaxies, lighting up huge regions of space.
Exactly.
And influencing the evolution of entire clusters of galaxies.
It's not just pretty pictures, you know?
Right.
These are dynamic processes that are literally shaping the universe as we know it.
That's incredible.
It is.
So with each new discovery, we're getting a clearer picture of how all of this works.
Exactly.
So speaking of pushing the boundaries of what we can see,
what
about the square kilometer array?
Oh, yeah, the SKA.
That's going to be amazing.
The SKA is going to be a complete game changer.
Right. It's like putting on a pair of super-powered cosmic spectacles.
Exactly. It'll be the largest and most sensitive radio telescope ever built.
So with all this power, are we going to be finding Inkathazo-sized objects everywhere we look?
Well, we're certainly hoping to find a lot more of these cosmic giants.
Okay.
But the real power of the SKA is its ability to detect faint signals from the very early universe.
So we'll be able to see back in time.
Yeah. Imagine seeing the first generation of giant radio galaxies.
Wow. So the ones that formed just a few billion years after the Big Bang.
Exactly.
We're talking about a time when the universe was still a baby.
It's incredible to think about.
What could studying those early galaxies tell us?
Oh, so much. We might be able to see how the first supermassive black holes formed.
Wow.
How they influenced the growth of the first galaxies.
Okay.
And even how the intergalactic medium itself evolves over time.
It's like we'll have a time machine that lets us see the birth of these cosmic giants.
It's really exciting.
I can't wait.
Me neither.
But for now, let's come back to the present.
Okay.
What are some of the key takeaways from Inkathazo?
I think the biggest takeaway is that the universe is full of surprises.
Yeah.
We're constantly learning new things, challenging our assumptions and revising our understanding of how things work.
And Inkathazo is a perfect example of that.
It really is.
It's a good reminder that we should never stop questioning and exploring.
Absolutely, and pushing the boundaries of what we think we know.
You know, it's crazy to think that we can learn so much about the universe.
I know, right?
Just by studying these giant radio galaxies.
It's true.
Like there are these cosmic laboratories that are giving us all these insights into how physics really works.
Yeah, they really push matter and energy to the limits.
Right.
Creating conditions that we could never, ever replicate here on Earth.
So by studying these systems, we can test all of our theories.
Exactly.
Gravity, particle physics, and even how the universe itself evolved.
It's amazing.
So Inkathazo and these other giant radio galaxies, they're not just pretty pictures.
No, they're not.
They're like giving us these clues about the fundamental building blocks of the universe.
Yeah, it's like using a giant telescope as a microscope.
Right.
To peer into how the cosmos works.
I like that.
It's a good analogy.
And speaking of giant, let's talk about the scale of these things.
Okay.
I mean, millions of light years across.
It's mind-boggling.
If you could travel at the speed of light, it would take you millions of years.
Millions of years.
To cross one of these galaxies.
It really puts things into perspective.
It really does. It's humbling. To think about all that vastness out there, all those stars and galaxies stretching out forever.
It just goes on.
And we're all connected.
We are.
You know, the atoms that make up our bodies, the Earth, everything around us, they were forged in stars.
We are stardust.
Stardust.
And these giant radio galaxies, they play a part in that.
How so?
Well, they're powerful jets.
Yeah.
And those energetic outbursts, they help to scatter that stardust across the universe.
Okay.
Seeding the universe with the building blocks of planets and life.
So we really do owe our existence to these cosmic giants.
In a way, yeah.
It's all part of this grand cosmic cycle of creation and destruction.
A dance of matter and energy.
And it's been going on for billions of years.
Billions of years.
It's amazing.
It really is.
And it's a good reminder that we're just scratching the surface when it comes to understanding the universe.
There's still so much more to discover.
So as we're wrapping up our deep dive here, what's one thing you want our listeners to take away from this?
I hope they come away with a sense of wonder and curiosity about the universe.
I think that's a great takeaway.
We live in an incredible time.
We really do.
We're making these amazing discoveries about the cosmos.
Almost every day.
And with these new telescopes like the SKA coming online, the future of astronomy is so bright.
Well said. I think Inkathazo is the perfect example of why we should never stop exploring and questioning and pushing the boundaries.
It's all about pushing the boundaries
of what we think we know.
Exactly.
Who knows what else is out there waiting to be discovered?
There's so much more to find.
Well, that's the beauty of science, isn't it?
It is.
It's a journey that never ends.
A never-ending journey of discovery.
Thanks for joining us on this deep dive today.
It was my pleasure.
We hope you enjoyed it.
Me too.
And that you'll keep exploring the wonders of the universe with us.
Definitely keep looking up.
Until next time, keep looking up, everyone.